So this is going to be a video explaining the systems that have decimals or fractions, like number 13. A lot of people totally freak out when there's decimals. The beauty of equations is that you can do whatever you want to an equation as long as you do it to every term on the equation, to both sides. So if you didn't want this to be a 0.5, you could multiply everything by 10, and that decimal would move over here, and it would become a regular 5x. Okay? So let's do that. We could multiply by 10, and you're going to get a new equation that reads 5x. Now, what would 4 times 10 be? 40. So you'd have 40y. That's kind of ugly, but oh well. It's better than decimals. Equals, and what's negative 1 times 10?
Negative 10.
Negative 10. So that's your new top equation. We're going to do the same to the bottom equation. We're going to multiply everything by 10. That'll give us 10x plus 25. Oh, wait a minute. I forgot the y up here on the 40y. Sorry. So on the bottom we have 25y. I'll stay consistent making that blue y. Equals 35. So what we did was we took an ugly looking decimal system and made it into nice integers, positive and negative numbers, no more decimals. So at this point, if you wanted to do substitution, you could pick an equation and get a variable by itself. Which one would you like to do? You want to pick the bottom equation?
Sure.
I'd pick the top, and I'll tell you why. If you pick the bottom and decide to get x by itself, you'd have to subtract 25y, then divide by 10, and 25 divided by 10 doesn't work out that great. But looking at the top equation, I could divide everything by 5, right? So if you get x by itself by getting rid of the 40, then you divide everything by 5, it'll work out nicely. So step 1 on substitution would be to pick an equation. I want to pick the top equation, and I want to get x by itself. So when I get x by itself, I'd have to subtract 40y first. So I'd have to rewrite that top equation. And that top equation rewritten so far is 5x equaling negative 40y minus 10. And I'd still have to get x by itself. I'd have to divide everything by 5. So my new top equation would be x equals negative 8y minus 2. We're going to substitute this x value, which is a variable expression negative 8y minus 2, into the equation we have not used yet, which is the bottom one of our modified system. So we're going to plug it right into x, right in here. So we're going to have 10, but instead of x, I put parentheses and I plug in the negative 8y minus 2 plus 25y equaling 35. So there's my new single variable equation. And I'm going to distribute 10 times negative 8y, that's negative 80y. 10 times negative 2 is negative 20. And then I bring down the plus 25y. Out of those three terms, I could combine negative 80y with positive 25y. And I will get negative 55y. Negative 55y. Let me rewrite the rest. Minus 20 equals 35. Wow, this is ugly. But let's keep going. I need to get the y by itself. I'm going to get rid of the minus 20 by doing plus 20. Plus 20. And thank goodness, what we have now is a 55 over here. The equal sign's still there. And negative 55y over here. Which means my final step would be to divide by negative 55 to get rid of that multiplication of negative 55 in front of the y. So divide by negative 55, divide by negative 55, cancel, cancel. Y equals negative 1. That's one answer. To find the other, what do? Plug it into any equation you want. Okay? So we could go back to the original Or we could go to our modified, after getting rid of the decimals, we could go back to this red one right here. Let's go back to the original. And like I said, there's many roads to the same place. Like on the original equation, instead of 0.5, 0.5 is really the fraction 1/2. So you could have written that top equation as 1/2 x plus 4y, but instead of y, we're going to plug in the -1, equaling -1. So all I did was change the 0.5 to the fraction 1/2, because 0.5 is 1/2. So what we have now is 1/2 x minus 4 equaling -1. And you get rid of that minus 4 by going plus 4, plus 4. So my new equation is 1/2 x equals 3. Final step would be to multiply both sides by 2. And that will give you 1x equals 6. And that was a lot more work than what I expected. I'm sorry. So anyway, the answer there is 6, -1. I'll be honest with you, I don't think I'm going to give you one of these on the quiz Friday. But at least you know how to do it, right? Let's look at one with fractions. Just again, I'm not sure. I don't think I'm going to give you one on the quiz Friday with fractions. But just to let you know, you could still work it through. See, a lot of people freak out with number 16 with that fraction. If you don't want fractions, what could you do? You can multiply everything by 3. You could get rid of it, right? So on the top equation, like let's say you just didn't want to deal with 1/3. Okay, so why not multiply everything by 3? If you multiply by 3, multiply by 3, multiply by 3, your new top equation will be 1x minus 3y equaling 9. And now you could deal with that new system instead of the one with the fraction. Okay, so instead of looking at the original, let's deal with this one. Which one would you like to pick, the top one or the bottom one? Top one, to get a variable by itself. Okay, so the top one is a little easy to get x by itself. You don't even need this 1 right there, so you could erase it if you want. And let's get that x value by itself up on top. I'm going to get the x by itself by adding 3y. My top equation will read x equals 3y plus 9. So that was step 1 on substitution. I'm now going to take the 3y plus 9, plug it into the equation I have not used, into the x. Why into x? Because it says x equals. If it would say y equals, if I would have solved for y, then I'd be plugging it into y. But I solved for x. It says x equals this stuff. I'm going to plug that stuff into x. So it really is going to read 2x, but instead of x, I'm going to be plugging in the 3y plus 9. And it still has the plus y equals 25. So now that's a single variable equation. All we need to do is simplify, distributed property, and combine like terms. So when you distribute 2 times 3y, that's 6y. 2 times 9, that's 18. Bring down the plus y. After distributed property, we're going to combine like terms. So do the 6y with the y. 6 plus 1y, or 6y plus 1y is 7y's. Bring down the plus 18. Bring down the equal and the 25. Now we have a 2-step equation to deal with. Hopefully it works out nicely, which it does. Subtract 18 to get y by itself. Subtract 18, and you're going to end up with, on the left side of the equal sign, you're going to have the 7y left over. So you're going to have 7y left over. And on the right side, 25 take away 18, that is 7. So on the right side you have 7. And that works out beautifully because when you divide both sides by 7, y equals 1. So you have your answer, y equals 1. You need your other answer. What do we do? Plug it in. And which one would you like to plug it into? The top original, the bottom original, or even the top modified? I'm going to go with the bottom original, all right? So 2x, let me write the bottom original over again. 2x plus y, but instead of y, I'm going to put parentheses and I'm going to plug in that 1. In this case, the parentheses aren't even necessary. Equals 25. So I really have just a 2x plus 1 equals 25. So if I subtract 1 on both sides, I'll end up with 2x equaling 24, which means that my final step would be to divide by 2. And my final answer for x is x equals 12. So your answer is x equals 12, y equals 1. On your answer sheet, I hope you write it as a coordinate, 12 for x, 1 for y. On the quiz Friday, if you have time left over, take your x value, plug it in, take your y value, plug it in. Make sure it works for both on the system. Again, I don't think I will give you one with fractions right from the start, but even if I did, it's really easy. Just get rid of the fraction by multiplying everything by the denominator. That'll get rid of the fractions. But this is just a third video explaining the ones with decimals and the ones with fractions, even though you're probably not going to have them on the quiz Friday.